Good morning, good morning. Voice and everything clear? Good morning. Hello. I'm asking voice and voice is clear? Okay, clear. Okay. Good morning, good morning, good morning, good morning. Good morning. Okay, so basic mathematics over. Now everybody started the physics. Teacher started physics, chemistry. They started chemistry. So first topic is what I will start the unit and dimension. Okay, unit and dimension. Every year you are we can see 3 question is coming from this chapter. So it is a easy but important also. And importance of this chapter is not only for this chapter. Unit we are unit conversion unit we are using in all physics, and we can say even chemistry also. So one thing first, build the habit, because suppose I have to set the NEET paper, then in the place like I can take how I can make the difficult. I will change the what, I will give the magnitude and different unit combination I will give. A student has the habit what, they only focus on the magnitude. So one thing what you have to build the habit, when you are reading the question you have to see the unit properly also, because sometimes what happened, only we focus on the magnitude, according to that we apply the formula, but the unit maybe some data they given in MKS, some data they given in CGS. That's why unit is very important. Read the question carefully. First find the unit, in which unit the data has given. According to that, first you have to decide, I am going to solve this problem in the MKS system, I am going to solve this problem in the CGS system. Don't pick randomly the magnitudes or the quantities, otherwise you will get wrong. So it is another way also that they can make the what, confusing paper, because they know that the students don't focus on the magnitude units. Okay, one thing like a small example, in the chemistry you have learned, in the physics you have learned. Suppose I am saying the number of moles formula. So number of moles formula is what, n is equal to pv upon rt. Okay, suppose I have given the pressure in Pascal, pressure I have given in Pascal, volume in liter. Okay, then what is the value of r you will take to get the mole? Maybe you remember or not, I'm just checking. Suppose I have given the pressure in Pascal, volume in liter, then what is the value of R you will take? Or to solve this problem, what you will do? So basically R, 3 values we marked up. Later in the kinetic theory, I will say, in the chemistry also they will say. So R, 3 value we marked up. 0.082, okay, 8.314 and 2, okay. So 0.082 we have learned in what is the unit of that? Atmosphere liter per mole Kelvin. Okay, when I'm using the 8.314, so we are using the joule per mole Kelvin. Okay, and 2 when we are using the calorie per mole Kelvin. Now according to the value what we have to follow the here units of the quantity. P I gave the pressure I gave in the Pascal. I will say that Pascal is the what, SI unit. Okay, volume I have given in liter. So liter is neither the MKS nor the CGS. Okay, so I cannot put randomly whatever the pressure they given, whatever the volume they given. First we have to decide, okay, I am going to solve in this, so I have to convert the pressure and volume in this unit, then I can solve. Getting my point or not? So randomly, like pressure I gave 10 Pascal, volume I gave 2 liter, you will put the value, you will not get the answer. Everybody got or not? So that is the importance of the unit, means we have to see the unit properly. According to that we have to solve 2-3 questions. Suppose they given and they confuse on the unit, then what will happen? Then you can lose the 2-3 question. So read the question, and with the magnitude of the quantity read the unit also. Okay, build this habit from the beginning, then it will help. Everybody got? Okay. After saying the good morning, everybody slept. Up to this, okay? What I said. Now, system of unit. How many system of units we are using in physics, or different to represent the different quantities? So we are generally in our syllabus, our problems, we are using MKS and CGS. Third one is about FPS. So what is a MKS? MKS is what? When length, mass and time. Length, mass and time. Length we are measuring in meter, mass we are measuring in kg, and time is the second. So that is the MKS system. MKS, M for meter, K for kilogram, S for second. Okay. It is a one system of unit, that is a MKS. Means if any quantity you are solving, like, then mass you are taking in kg, then length we have to take in meter, time we have to take in second. It is a MKS. Okay. Second one is what? CGS. CGS is what? Centimeter, gram, second. Okay. So means length unit we are using the centimeter, mass unit we are using the gram, and time unit we are using the second. That is a CGS. Okay. So mainly we are dealing with these two system of unit, MKS and CGS. Okay. Third one is what we are using mainly in the other countries, FPS. FPS is what? Foot, pound, second. Foot, pound, second. So this about the third system we will never talk. So we will deal only with the MKS, either MKS or CGS. This everybody got or not? Okay. And with these three, there is another unit we are using international in the international level, that is a SI unit. What is SI unit? International System of Unit. So we have decided what? Like suppose I have the mass. So mass, suppose I am writing kg. Okay, that is a simple. Okay, but suppose I am writing the force. I need the force data. So basic formula of the force everybody know, like F is equal to ma. Okay, suppose I want to represent the force, and I want to find the unit of force. Okay, so force basic formula is what? F is equal to ma. Okay, m is the mass, a is the acceleration. If you remember, then mass I can write in kg. Suppose acceleration unit is what? Meter per second square. Okay, means force, what is the unit of the MKS unit of the force? Kg meter per second square. Similarly, if I want to write the energy, so energy, what is the unit? Energy unit is the kg meter square per second square. Later I will say how to find the unit and all. So this kg meter per second square is the unit of force. Kg meter square per second square is the unit of the energy. Okay. Suppose you are buying the biscuit. Okay. And on the biscuit packet, suppose it has written like chocolate, when you are buying biscuit, you are buying, so they mention the energy. So suppose their written is 20 kg meter square per second square. It will be complicated or not? Representation of this unit is a complicated. It is an energy unit. But when we are writing like this way, it seems what? It takes more place also. Okay. And so many other quantities are there. They depends on the large number of quantity. Their unit is very big. So what will happen? The representation is difficult. Okay. So what we have done? These units we replace by the one international system. They have replaced these unit by the one name. Okay. Like kg meter per second square. On the honor of the Newton, we have replaced this by this as a Newton. Okay. So kg meter per second square we can represent as a Newton, and it is an easy representation. Means force I am saying like 10 Newton, so easily everybody get this. I am representing what? Force. Okay. Similarly, kg meter per second square we are representing as a joule. On the honor of the scientists, we gave the different name. Okay. So this kg meter per second square we are representing as a joule. So this Newton, joule, Pascal. Pascal is the honor of the Pascal. Watt. Tesla, Weber, Henry, so many units you will learn. Poise, these are the SI unit what we are using in the international level, which unit we are using, because this unit is the representation is complicated. Everybody got or not? So what is SI unit? International system is following one unit. Okay, and its representation is more simple. Okay, so that's why like on the honor of scientists we have given the name, and that we are taking as a international system of unit. Okay. And most of the, we can say, SI unit and MKS unit are same. SI unit and MKS unit are same. Like suppose I gave the force in the Newton. I gave the force value in the Newton. Then acceleration I gave, mass I am asking. So SI unit I gave, so SI unit we can take as a MKS. It means in the calculation we have to follow the MKS system. I repeat again, if they given the SI unit, okay, like they have given the energy in the joule, okay, and I need the kinetic energy formula. I'm using K is equal to half mv square, okay. So energy is in the joule, so mass I will put in the kg, velocity I will put in the meter per second. It means we have to follow the MKS. So when SI unit has given, it means we have to follow the MKS system. Everybody got or not? So everybody got why we have introduced this SI system. Reason is what? To represent the units simply, we have used what? We have introduced the SI system. Okay. Are everybody got or not? Okay. So many SI system. Later all the quantities you will learn. Newton, here I have shown joule, watt, what is the power, SI unit of the power, Tesla, SI unit of the magnetic field, Weber, SI unit of the magnetic flux, okay, Henry, induction, so self-induction. So many quantities we will learn, okay. So what I said, when SI unit, some data you are following, so you have to decide, we have to solve this problem in the MKS system, okay. So all the quantities we have to convert in the MKS system, then we can solve, okay. Then next thing, fundamental quantities, okay. This name everybody know, and everybody know how many fundamental quantities are there. Who will say what is the definition? I'm not asking, everybody know that there are the 7 fundamental quantity, and you know that those 7 fundamental. I'm asking what you understand from by fundamental quantity. What are the fundamental quantity, or this is also called the base quantities? What are the fundamental quantities or base quantities? Who will say? It does not depends. It does not depends. So listen, fundamental quantities are what? It can't be derived from the other quantities. They cannot be derived. One thing, God has not said that these 7 you have to take as a fundamental. We have decided, international physics has decided these 7 quantities we are taking as a fundamental. Why there is a required these fundamental quantities? So one thing what? Means if we have not decided these fundamental quantities, so for every quantity what we are learning, what we know, for that we have to put some symbol. Like everybody know mass, if you have to write, then you will write the what? M or kg. Okay, if you are writing the length, you will write the m, meter or L. Like this way, suppose you are learning the magnetic field, you are learning the force, you are learning the energy. For every quantity we should have the one symbol. So like that way, this symbol we cannot, all symbol we cannot mug up, and it will be very complicated. So then what we do, we have taken the 7 quantities as a fundamental. Okay, we have taken 7 quantity as a fundamental, and rest whatever the quantity exists, that we can write in the terms of these 7 fundamental. Those other quantity except that 7, we can take the earlier they decided this 7 fundamental system. If we are taking the different also, then we can do. Later we will discuss the problem when we will change the fundamental system also. And in the NEET, so many years they ask that question. Okay, but international physics decided what? 7 fundamental we have to take. This 7 quantity we have to take as a fundamental. Okay, when you are taking them as a fundamental, then other quantity we can express in the terms of these 7. Okay, so means for different quantity we should not need the new representation. We can represent those quantity in the terms of these 7. Okay, so that's why these are called the fundamental. So what is the definition of fundamental? Fundamental quantities are what? They are independent. They are independent of the other quantities. Means they do not depend upon other quantity. Even fundamental quantities are independent of each other also. I repeat again, what are the fundamental quantity? Fundamental quantities or base quantity, they are independent of the other quantity. They are independent of other quantity, and all fundamentals, they are independent of each other also. Okay, means one fundamental does not depend upon the other fundamental. Means they are independent of the other quantity. Everybody got or not? So fundamental quantities are what? The quantities, those are independent of the other quantities, or even all fundamentals are independent of each other also. So we can say these quantities are fundamental quantities. Everybody got? Rest, except these 7 quantities, other quantity we can express in the terms of this base quantity. Other quantities are called derived quantity. So I am repeating again, fundamental quantities are what? The quantities, they are independent of the other quantities. Okay, so they are called fundamental. Rest quantity, except the fundamental, rest quantity are what? Rest quantity are the derived quantity. Okay, like force. Force I can write in the terms of mass, length and time. So force is derived. Force is derived. Everybody got or not? So how many fundamental quantities are there? There are 7 fundamental quantities. Okay. Later I will use the one. I will give the one question, and how you understand that definition or not, then you will give the answer. Okay, so that's why I said the definition of the fundamental also. Okay, so there are 7 fundamental quantities. Everybody know the names. Number 1, 3 I will say, last 4 you will say. Mass, length, time. Now fourth one, temperature. That is a K. Next, okay, mole. Luminous intensity. Okay, good. So temperature, number 5. This we can say the amount of substance. It is a mole. Next, luminous intensity. Earlier this chapter was there, but now we will never talk about the luminous intensity, but it is taken as a fundamental quantity. So luminous intensity unit is what? Candela. So that's why symbol is the CD, but we will never talk about that. Okay, and one is the electric current. which we are using, that first I am writing. So electric current A, or sometimes they will use the I. 7 is what? Luminous intensity. That is a CD. Okay. There are the 7 fundamental quantity. It means what? Rest of the physical quantity we can express in the terms of these 7 fundamental quantity. Okay, and they don't need any, their representation does not need any other quantity. Like mass is the independent, mass required only mass m. Okay, like that we have decided the 7 fundamental quantity. It is not any like means I can take the mass as a fundamental, but the international system has decided these 7 we have to take as a fundamental. Okay, means if suppose I am taking the mass as, I have not taken the mass as a fundamental, then mass we can say it can be derived. Suppose mass depends upon the volume of the body and density of the body, so mass can be derived, but we have taken mass as a fundamental. Okay, so these 7 we have taken as a fundamental. Okay, so a small question I am asking. These what is the question? Which system cannot be taken as fundamental? So here I have given the mass, length, time. Means suppose you have to make your fundamental system. We are going to make our fundamental system, and we are deciding this quantity we have to take as a fundamental, but we have to follow the condition of the fundamental quantities. So which we cannot take as a fundamental system. So suppose the question, if I am saying among the given option, which is the which represent the fundamental system. Let's first listen. Okay, among the given option, which represent the fundamental system. It means in that question I am asking about our fundamental system. Our fundamental system is what? Mass, length, and time is fundamental. So if this question is there, which system represent the fundamental system, then we can go to the option 1, because option 1 what I gave, mass, length, and time, that we are taking as a fundamental. But here what I am saying, which system cannot be taken as fundamental. So means according to the definition of fundamental, which we cannot take as fundamental. Now what is the answer? 3. Okay, somebody is saying 4. Next. Four. Now listen. Answer is second. Answer is the second. First thing, I think nobody has confusion in the first option, mass, length, and time. That we can take as a fundamental. Just now we have discussed. Okay. So first option we can take as a fundamental or not? Yes. Second, what is the definition of fundamental? Means they should not depend on each other also. Okay. Means they should be independent. There should be independent quantity. Mass, volume, and length. If you see the volume and length. So volume I can say what? Volume is equal to L cube. Volume is equal to what? L cube. So volume I can represent in the terms of L. Then why unnecessary I am wasting one fundamental? Either I can take the volume as fundamental or I can take the length as a fundamental. Why? If I am taking the volume as a fundamental, then length I can write V to the power 1 by 3. Then I can represent the length in the terms of volume. If I am taking the length as a fundamental, then volume I can say as a L cube. Okay. So means any one I can take as fundamental, but both I cannot take as a fundamental. This everybody got or not? So what is the definition of fundamental? They should be independent of each other also. Okay. But here volume and length if I am taking as fundamental, so volume I can say volume depends upon length, or length I can say depends upon volume. So anyone I can take as a fundamental, both we will not take as fundamental. Getting or not? Now come to the third. Who has the confusion in the third? Mass, velocity and time. Can we take as fundamental? Yes, we can take as fundamental. Why the people are saying the third option? Because our habit is what? Mass, length and time. And we think that velocity is the derived. Okay. In our actual system, what is a SI system? What is a fundamental system we learned? In that velocity is derived. But here in this question, I'm asking which we cannot take as fundamental. So suppose you are making your fundamental system. Can you take the mass, velocity and time as fundamental? If I am saying mass, velocity and time, if I am taking as fundamental, then can we take? Yes, we can take. Everybody got? Okay, so mass, velocity and time. Okay. Now velocity depends upon time. Velocity depends upon time. Okay. So who is saying velocity depends upon time? So suppose I am saying in 20 seconds a body is moving. A body is moving. Listen. Who has the confusion that velocity depends upon the time? One thing. Okay, now listen. Mass, velocity and time. Mass, velocity and time. If I am saying the velocity, suppose you know the velocity formula. So velocity I can write displacement upon time. Displacement we are writing as a length L upon T. This everybody got? Okay, now listen. If I am taking the length and time as fundamental, actual our system, if length and time is fundamental, then velocity we can write as a length upon time. Velocity we can write as a L upon T. Okay. So if I am taking the length and time as fundamental, then velocity is derived. Okay. Because then velocity we can say it will depend upon the length as well as time. But suppose in this I am taking the velocity and time as fundamental. If I am taking velocity and time as fundamental, then length I can write as V into T. Length I can write as V into T. So length will be derived. Length will be derived. Velocity and time I am taking as fundamental. Only saying the time, can you say what is the velocity? Like I said, in 20 seconds, a body is moving. In 20 seconds, what is the velocity? So only time I have given, then I cannot say the velocity. For velocity, I require displacement and time. Okay. Suppose I am saying I have given the time. Can I write the length? No. So in this formula, velocity is equal to length upon time. If any two I am taking, any two I can take as fundamental. So third one will be derived. Like I took the velocity as fundamental and time as fundamental. Then length I can represent V into T. So length is the derived, and length derived quantity I can write in the terms of velocity and time. If I am taking the length and time as fundamental, then velocity I can say it is a derived. It is a what? L by T. If I am taking the V and L as a fundamental, then what will happen? Time will be derived. Why? T is equal to L by V. So any two I can take as fundamental. So third one will be what? Derived. Everybody understood or not? If any confusion, then say which we cannot. So this I can take as fundamental or not. Mass, length and time I can take this, we know it is a fundamental. Mass, velocity and time we can take as fundamental because then length will be derived. Length will be derived. Okay. Okay. And then here mass, volume and length, that we cannot take as a fundamental. Okay. So answer is the second one. Acceleration is not a fundamental, but suppose you are defining your fundamental system, then you can take. But acceleration is the what? Derived quantity. Acceleration is what? Velocity upon time. So it depends upon the and velocity is also derived. Then acceleration, how it can be the fundamental? In any problem, if you are making the system or they are giving the question, then maybe according to the given problem, acceleration also we can take as a fundamental. Later I will discuss some problem like this. But in an actual system, acceleration is not a fundamental. Acceleration is the derived. Okay. But in the problem when we are making, so in the numerical problem, we can take any fundamental system. Understood or not? So in this type of problem, what we have to do, we have to follow the definition of the fundamental. Means one fundamental cannot write in the terms of other fundamental. They should independent of each other. But in the second option, volume I can write in the terms of length, or length I can write in the volume. Length I can write in the terms of volume. So either I can take volume as fundamental or length as fundamental. Understood? Okay. So these 7 fundamentals quantities everybody got. Now there is another 2 special quantities. Even we cannot say they in the category of the fundamental among the 7 fundamental, and we cannot say they are the derived also. So those 2 special quantities are what? Angle. One is the plane angle, one is the solid angle. Means suppose I am saying the angle can you get from these 7 fundamental? No. Okay. So there are the 2 special unit. We can say we have not put in the terms of fundamental. They are not the fundamental, or we can say they are not the derived as well. Okay. So these 2 quantities are what? One is the plane angle, one is the solid angle. Okay. Okay. So plane angle and solid angle. About the plane angle I discuss in detail in the basic mathematics, but in short I will say what is a plane angle, how we will find the plane angle, and what is a solid angle. Solid angle we are not going to use anywhere in the physics, but here we have to know what is a solid angle, what is the unit of solid angle. Okay, so something we have to know about the solid angle. Okay, so plane angle. So what I said about the plane angle, suppose you have the arc and then you are joining with the center. So what is the basic formula of the angle? Angle is equal to what I said, angle is equal to arc upon radius. Angle is equal to, or plane angle or angle is equal to arc by radius. In the basic mathematics that I said. So plane angle means suppose you have the 2-dimensional like circle you have, or ring, suppose I am saying you have the ring. If you are taking the small portion of the ring and join with the center, so what is the angle subtended by the portion of the ring at the center? How we can find? Portion of the ring, length, that is the arc upon radius. So angle is equal to what? Arc upon radius. Okay. So basically we are defining due to the circle or arc, means plane. In the plane we are defining the angle, so that is a plane angle. Plane angle basic formula is what? Arc upon radius. Okay, what is the unit of the angle? Okay, in detail I discussed in the basic mathematics. So unit of the angle, default unit means even we can say unit is what? Radian. Degree, if they are giving then only degree. Otherwise, what is the unit of the angle? Radian. Like suppose I am saying a body is rotating, it has the angular displacement theta. I have not given anything. It's angular displacement theta. So if unit required, it means this value is in the radian. So nothing like given, only theta they are saying. So this theta we have to take in radian. Till they are not mentioning like angular displacement of the body is theta degree, then it means we have to take degree. If they have not given anything, it means that unit is what? Radian. So default unit we can say for the angle is what? Radian. Angle between the two line is theta. What is that theta? Radian. Everybody got or not? Okay. Now, what is a complete angle? If I want to find the complete plane angle, so complete plane angle, complete arc means what? Circumference of a circle. Circumference of a circle is what? 2 pi r by r. R cancel out, how much we got? 2 pi radian. So complete angle is what? 2 pi radian. Okay. Then now we can say relation is what? 2 pi radian is equal to 180 360 degree, because complete angle we know that 360 degree. Then what is a pi radian? Pi radian is equal to 180 degree. This relation you have to remember. Completed. And I said to degree to conversion, degree to radian conversion, radian to degree conversion, that we have to remember. And how we will convert, everybody know. I said like here, if you focus on the magnitude, so pi radian and 180 degree. In which system we have the small magnitude? Don't focus on the unit. Pi and 180, which is more? 180 is more. 180 is more. Okay. So when we are converting the angle from radian to degree, so in the radian, if you see this relation, in the radian we have the magnitude pi. Pi is what? 3.14. Okay. And in degree, what is the magnitude we have? 180. So when we are converting the angle from radian to degree, so magnitude should increase. Then we can say whatever the angle they given, that we will multiply with 180 by pi. Like suppose I gave x radian, convert into degree. So x radian into degree. So x into 180 by pi. 180 by pi. Okay. If I am going to convert degree to radian, so magnitude should decrease. So suppose I am saying the x degree, convert into the radian. So x into pi by 180. We have to reverse the ratio. X into pi by 180. So radian to degree, if any angle you want to convert, radian to degree, so magnitude should increase. So whatever angle they given, into 180 by pi. If we want to convert degree into radian, then degree to radian, what we will do? Magnitude has to decrease. So whatever angle they given, into pi by 180. This I said in basic mathematics, that everybody has to remember, because in so many places this conversion we will do. Okay. Everybody got? Okay. Okay. Number 2 is what? Solid angle. Solid angle is what? Like suppose just imagine the watermelon when we are eating. So watermelon, when we are cutting the watermelon, so if you think that green part and this red is joined at the center. Okay, when you are getting the piece of the watermelon, so this is the green part. Okay, and it is a join at the center. Okay, So basically, what is a solid angle? When we are defining for the three-dimensional, in the three-dimensional when we are defining, then we can say we are using the solid angle. So like plane angle, it is the area subtended by the arc. Area subtended by the arc. Yes, cake also we can say. Area subtended by the arc. But in the solid angle, angle subtended by the area. Angle subtended by the area. If you imagine one piece of the watermelon, a small piece of like you cut the watermelon and you are getting the one piece. So this green area that is joined, red is joined at the center. Now you can think whatever the angle it is making at the center, that is a solid angle we can say. So solid angle, similar formula is there. Only solid angle means what? In the case of the plane angle, we are taking the arc. Here we will take the area. Okay. So what is a solid angle? We can say solid angle is the area subtended by the arc upon r square, where r is the radius. Clear? Okay. Now suppose I am saying, what is the unit? Everybody know maybe unit of solid angle is equal to steradian or SR we are writing. Okay. Unit is the what? Steradian. What is a complete solid angle? Okay, suppose you have the whole complete watermelon, then how much angle it will subtend at the center? So when you have the complete watermelon, then what is the total area you will have? 4 pi r square, because area of the sphere is what? 4 pi r square. So for the complete, if we want to find the complete solid angle, so we have to take the whole area. Whole area is what? 4 pi r square. Upon r square, what you got? 4 pi. So then I can say the complete solid angle is what? Complete area is what? 4 pi r square by r square, r square, r square cancel out. What we got? 4 pi SR. Okay. So everybody got this complete solid angle, complete plane angle. What is the unit of the plane angle? Radian. What is the unit of the solid angle? Steradian. Except this place, we will never talk about the solid angle, but in the unit and dimension, this you have to know. Okay. Completed. Okay. So length, mainly length unit we are using meter, centimeter, kilometer, millimeter. This we will deal in a whole physics. But sometimes suppose they are asking in the JEE Main 2 year back they ask, and in NCERT it has given also for the large unit, large distance unit. The 3 unit they have given that you have to know it is a unit of the distance. They ask in the JEE Main which is not a unit of the distance, like that they ask. Okay. So 3 large unit of the distance we are not using generally, but it is a unit of the distance. One is the light year. One is the light year. Light year is the unit of the distance. It is not the year. It is not the time. It is a unit of distance. What is a light year? It is a distance traveled by the light in 1 year. It is a distance traveled by the light in 1 year. So light year is the unit of distance. Light year is the unit of distance. This everybody got? Okay. So light year is the unit of the distance. If you want to calculate the what is a light year, how much meter is equal to how much kilometer. So light year, distance traveled by the light in 1 year. 1 year, first you will convert in second. So one day, how much second? One day, how much second? Tell fast. One day, how much second? Wow, one day 3600. One day, how much second is there? 86,400 second. 1 hour is equal to 3600. This you have to remember, because in thermal we will use this data also. So what I said, in 1 hour 3600 second. In one day 24 hours are there. So 24 into 3600, you will get 86,400. So in 1 hour is equal to 86,400 second. Okay. Got it or not? So what is the light year? Light year is the distance traveled by the light in 1 year. 1 year, how many days? 365. 1 year, how many days? 365. In one day, how many are? 86,400. Multiply that, you got the total time. And the speed of light is what? 3 into 10 to the power 8 approximately. Then you will get the distance traveled by the light in 1 year. So light year is the unit of the distance. This everybody got? Second is what? Second is what? Astronomical unit. Astronomical unit. I will write all. One is the what? Some large unit of distance. Number one, light year. Okay. Number two, what I'm saying? Astronomical unit. That is what? AU. What is astronomical unit? Anybody know? So astronomical unit is also the unit of distance. What is the astronomical unit? It is the average distance between the earth and sun, or we can say average radius. It is the average distance between the earth and sun, or average orbit radius of the earth around the sun. I repeat again, it is the average orbit radius of the earth around the sun, or average distance between the earth and sun. We know that earth is not revolving in the circular orbit. That's why distance of the earth from the sun is changing at the different point. Okay, that's why we are saying the average distance between the earth and sun, or average orbit radius of the earth around the sun, is the astronomical unit. This everybody got or not? So astronomical unit is what? Average distance between the earth and sun, or we can say the average orbit radius of the earth around the sun. This everybody got? Third one is what? Parsecond. What is a parsecond? Anybody knows? What is a parsecond? So listen, parsecond is what? Definition is not that much important, but at least everybody has to know these three is the one unit of the length. If they are asking, so these three are the unit of the length. So parsecond is what? Suppose one AU subtend an angle of 1 r/second. 1 AU. Isha, you have not seen the complete definition. So here, suppose the distance between the earth and sun, that is what? It is a changing. So basically, it is a what? Average distance is what? This average distance is what? Astronomical unit. Average distance between the earth and sun is the astronomical unit. Okay. So here, if you see, this is the average distance between the earth and sun, that is the astronomical unit. The distance at which average radius, or we can say AU, average, like astronomical unit, makes an angle of 1 second, that distance is the 1 parsec. I repeat again, astronomical unit, or the average distance between the earth and sun, the distance at which this AU is making an angle of 1 second, this AU is making an angle of 1 second, that distance is equal to the 1 parsec. Like here, this point I am taking, suppose P, at the P, this is the AU, average distance between the earth and sun. AU makes an angle of 1 second at the distance, that distance is the what? 1 parsec. That distance is equal to 1 parsec. Maybe this week it will continue in the YouTube, 1 or 2 week maximum. Everybody got or not? But definition, that not much important, but we have to know the astronomical unit, parsec, and the light year is also the unit of the distance. This everybody got? Completed? Okay. Now we will come to the dimension. So what do you understand from dimension? So one thing, what dimension, like suppose I am saying what is the dimension of the, in general we talk about like this, what is the dimension of force, then we say ml t minus 2. But what is the actual meaning of the dimension? So dimension is what? It is the power of fundamental quantity in the dimensional formula. I repeat again, what is the dimension? What is the meaning of dimension? It is the power of fundamental quantity. It is the power of fundamental quantity in the dimensional formula. Like suppose I am saying dimensional formula of the force is mlt minus 2. mlt minus 2. It is the dimensional formula of the force. What is the dimension of mass in the dimensional formula of the force? So dimension of mass is 1. What is the dimension of length in the force? 1. What is the dimension of time in the force? Minus 2. So what is the meaning of dimension? It is the power of fundamental quantity. It is the power of fundamental quantity in dimensional formula. Everybody got this or not? So in general we will talk about like what is the dimension of the force, then option like mlt minus 2, like, so it means they are talking about the dimensional formula. But in some places, suppose they use the definition and they are asking what is the sum of dimension, of the all fundamental quantity in the force. Suppose I am saying what is the sum of all dimension in the dimensional formula of the force. It means, then here it means they are asking that what is the meaning of the dimension, then ml t minus 2. So m1 l1 t minus 2, that you can do the summation. Everybody got or not? That I am saying, in the YouTube, maybe this week or maybe one or two more week we will go YouTube live. After that we will start in the app. This everybody got? Okay. One or two things you have to know. Dimension of numerical number is what? Dimension of numeric constant is 0 or it is dimensionless. Means if I am saying any number does not have unit, pure number does not have any unit or dimension, we can say. So like 5, I have given the 5, means it does not have any dimension. Okay, it is a dimensionless. So numeric constant does not have dimension, but physical constant have. Physical constant means Planck constant, it is a physical constant. Gravitational constant, okay, force constant of the spring. So physical constant have the dimension, but numeric constant we can say it is a dimensionless, because pure number does not have dimension. So in any formula pure number is coming, it is a dimensionless. Okay. Suppose I am saying, what is the dimension of the delta x, where x is the distance. Okay, so suppose I am saying I am subtracting velocity from the velocity. I am subtracting two velocities. What you will get? Which unit you will get? I am subtracting the two velocity. Which unit you will get? I am subtracting two velocity. Which unit you will get? Meter per second, because velocity minus velocity we will get the velocity. Okay, means velocity minus velocity we will get the unitless, we cannot say. Okay, so when we are subtracting the two quantity, final will also be that quantity. Like mass, 2 kg mass minus 1 kg mass, I will get 1 kg mass. Okay, so we can say the quantity and the change in the quantity will have the same dimension. Like V and delta V has the same dimension. A and delta A has the same dimension. Everybody got or not? That I have written in the second. Change in the quantity has the same dimension as of the quantity. Everybody got or not? Okay. So right now we will not mug up all the dimension whatever we are going to learn in the physics. Okay. Few dimension we expect that everybody has to remember, because they are not directly asking the dimension of this quantity. Maybe they can use in the combination. Okay, so that's why some quantities are there, we have to know their dimension. Okay, but all physical quantity we cannot cover now, because maybe as a long term student you know, but some students don't know all the formula. So that's why when we will learn the different chapter, which new quantity is coming there, it is our responsibility. We have to find their dimension and we have to learn the basic formula of the quantity, because all the dimension we cannot mug up. But when you know the basic formula of the quantity, by using the formula we can find the dimension. Okay, so it is your responsibility when you are learning the new quantity, you have to find the dimension of the quantity. Okay, but few dimension we have to remember, that I'm going to write. Okay, so everybody know distance, displacement, whatever we are saying, distance or displacement, or I'm saying length or radius, diameter, whatever they are saying, arc, circumference, is basically all are representing the length. All are representing the length. So what is the dimension? Dimension will be what? L. Okay. What is the dimension of volume? So any volume when we are using, so volume is what? Whether it is a volume of, like that I am saying, na. Maybe this 1 or 2 week maximum we will go to the online YouTube live. After that we will start in the app. So volume is what? Volume, any volume we are multiplying the 3 dimension, like volume of the cube, L into B into H, volume of the cuboid, L into B into H, volume of the cube, side cube, volume of the sphere, 4 by 3 pi r cube means r, L, volume of the cone, 1 by 3 pi r square h, means any volume we will always multiply the 3 dimension. That's why dimension of volume is what? L cube. Similarly, area, what we can say, area is equal to L square. Okay. What is the dimension of density? Density basic formula is what? Mass upon volume, mass upon volume. Now mass is a fundamental, volume dimension we got L cube, then what we can say? ML minus 3. Okay. These, you know, but I'm writing because who don't know for them. Velocity or speed, whether it is a vector or a scalar, doesn't matter. The velocity or speed basic formula is what? Distance or displacement upon time. Then what is the dimension I can say? L by T or LT minus 1. Acceleration. So acceleration basic formula is what? Rate of change of velocity, delta V by delta T. Now change in the quantity or the quantity has the same dimension. So velocity dimension is what? LT minus 1 upon T. Then what we will get? LT minus 2. Completed. Okay, dimension of force. So force basic formula, Newton's law, F is equal to what? Ma. Now M is fundamental, A dimension we already written. Then what is the dimension of force? MLT minus 2. Whatever I am writing, that directly you have to remember. Energy, any form of energy, potential energy, kinetic energy, spring energy, electrostatic energy, any energy or work, in the dimensionally they are same. Okay, dimensionally they are same. So energy or like kinetic energy, half mv square, whether you are using that formula, you are using mgh, that formula, or work you are using force into displacement, that formula. By using that, energy dimension or work dimension will be same. That is what? ML2 T minus 2. Completed. If I am saying power, so power is basically what? Rate of change of energy, rate of doing work. So energy upon time. Energy dimension ML2 T minus 2 upon time, what you will get? ML2 T minus 3. These are the basic formulas because we have learned in the class 9th and 10th also. So that's why these dimension you have to remember. Completed. Momentum, linear momentum, you can say linear momentum. So momentum formula is what? Mass into velocity. So that is what? MLT minus 1. Only a few more. Okay. Next, this also we expect that you have to remember gravitational constant. Capital G. So for the capital G, simplest formula is what? Newton's law of gravitation, F is equal to G m1 m2 by r square. By using that, we can get the dimension of capital G, but try to remember this dimension because this they are giving in so many problems with the combination of different quantity. Okay. So how we can find G dimension? F is equal to G m1 m2 means m square by r square. Then capital G, what I can say? FR square by m square. Now all dimension we know in the right hand side. So dimension of G, what we got? Force dimension is MLT minus 2, MLT minus 2. R square means L square upon M square. Then what we got? M minus 1, L 3T minus 2. This is the dimension of the capital G that everybody has to remember. M minus 1, L 3T minus 2. I will show some problem later, means how we can use this dimension and to get the answer fast. Okay. M minus 2. Planck constant, how you will find the dimension? So for the Planck constant, simplest formula is what? E is equal to h nu. It is the most simplest formula for the Planck constant. E is equal to h nu, where nu is the frequency. Frequency is what? 1 upon time period. Okay. So frequency I can write as 1 by t. Okay. Energy already I know ml2 t minus 2. Then now dimension of h, what you will get? Dimension of h means E dimension ml2 t minus 2. Dimension of h and new dimension what you will get? 1 by t. Cross multiply ml2 t minus 1. ml2 t minus 1 is the dimension of h. Okay. Now one dimension, that one quantity that we are using frequently, but choice is your, no need to mug up, but basic formula everybody has to know. It is a what? Permittivity. Permittivity of the like medium or the any medium or the free space or the vacuum you have learned. Epsilon. Okay. Epsilon dimension, choice is your, you can mug up. Otherwise, we are using the Coulomb's law to get the dimension of epsilon. Okay. So permittivity. In which formula we are getting that? Its simplest formula is what? Coulomb's law. 1 by 4 pi epsilon into q square by r square. So if I need the epsilon what I will get? Q square. Q is what? Charge. Charge is what? Q formula we know. Q is equal to IT. Q is not fundamental, so we are taking the current as a fundamental. So charge I can write as a I into T. I is the fundamental, T is the fundamental. Then Q what you got? A square, T square. Force came down. So force dimension is what? ML T minus 2. Okay. And R square dimension is what? L square. 4 pi is the constant. It does not have dimension. Then after solving, you will get the dimension of epsilon. That is equal to what? M minus 1 L minus 3, T will go up, T to the power T to the power 4 and A to the power 2. This is the dimension of the epsilon. Completed. That is correct. Epsilon. So it is not required to mug up, but by using this formula, we can find the epsilon dimension faster. Okay, so because epsilon and mu required, so later I will say how we can find the mu by using the epsilon. Okay, but epsilon dimension, it is the simplest formula. It is easy to find. So by using the Coulomb's law, we can find the dimension of the epsilon. Up to this, everybody got? Completed. Okay, so few quantities I will say in the next class. Okay, and after that how we are using the different quantities, how they will give the combination of the quantity, and we will do the we will find that dimension when they are changing the fundamental system, how we will do the problem. Okay, any doubt anybody has? So in the YouTube, some live, some disturbing elements are there, but we should not taking care of them, because that type of people will always be there. If you will go ahead, somebody will pull your leg. Okay. Okay, then bye bye.